Hi guys, in a previous email made by Mr. Bauer, you guys already learned some operations, basic operations of matrices like multiplications, scalar multiplication, addition and subtraction. In this video, we're going to learn multiplying matrices. The first thing you have to remember is not all matrix, the product of the two. For example, I have two matrices A and B, but we are not sure that the product of these two matrices is defined or not defined. So there are rules for that. For example, we consider these two matrices A and B. To know that the product of A times B is defined or not, we have to write down first. We have to write down the order of the matrices. So the order here of the matrix A is the number of rows times number of columns. So we have 2 rows in here and 3 columns in here. So the order of matrix A is 2 rows times 3 columns. Remember here, 2 times 3 here is not 6. It is 2 rows times 3 columns. And the order of matrix B is 3 rows times 1, 2, 3, 4 columns. So it's going to be 3 times 4. Okay. So first, I want to see if A times B is defined or not. The answer is defined, but let's check it out. What is the rule? All right. So A times B, the order of A is 2 times 3 as we found here. And the order of B is 3 times 2. So when you write down the orders and you found the number in the numbers here are the same, 3, 3. So this means that matrix A times matrix B is defined. And the answer will be matrix C. And matrix C has the order of 2 times 4. So the outer number here, the outer numbers here are the final result or the order of the final results. And the inner here, they have to be exactly the same, 3, 3 or 2, 2 or 4, 4 or 5, 5 to be identified that their product is defined. Okay, so how about B times A? In algebra, we know that 5 times 3 equal with 3 times 5 equal with 15. But whether this rule is exactly the same with multiplying matrix or not, check it out. So now if I want to find B times A, I write down the order of B is 3 times 4. And then the order of A is 2 times 3. Okay, so you can see here the inner numbers here are different, 4 and 2. So straight away you know that B times A is undefined. There you go. Now, there are some more examples to consolidate about the rules of multiplying matrices. So we have here matrix A, matrix B, and matrix C. And I wrote that down, the orders of the matrices. So first with A, 2 rows times 3 columns, so 2 times 3. With B is 3 rows times 2 columns, so 3 times 2. And C is 1 rows and 3 columns, so it's 1 times 3. My question is, A times B, whether these product, stay if the following products are defined, like it's possible or not to find the products of the following questions. All right. For example, A times B. Is it defined or not? All right. So A times B, we write that down. A is here, B is here. And the order of A is 2 times 3. Order of B is 3 times 2. Just write that down. And then we circle the inner numbers. 3 and 3. So when the inner numbers exactly the same, in this case is 3, 3. All right, then it means definitely the product of A and B is defined. Okay, so it means A times B is defined. Okay, And then what is the answer? If A times B equal what? If A times B equals C, then what is the order of C? So the order of C is, of matrix C, is the outer numbers here. It's going to be 3 and 2 and 2. So C is going to be a square matrix 2 and 2. So it's going to be like this with 2 rows and 2 columns. Okay. Now another question is B times C. All right. B times C, is it defined or not? We write down the order of B is B here and times C. So the order of B is 3 times 2 and C is 1 times 3. It's not defined because the inner numbers are different. So this one is undefined. Okay, so how about C times B? All right, write that down. C times B. C is 1 times 3, the orders, and B is 3 times 2. All right, so this time we can see here 3 and 3. The inner numbers are the same, so the product of B and C times B is defined. So as you can see here, B times C is different with C times B. B times C is undefined, but C times B is defined. Okay, so it's different with algebra. In algebra, as we mentioned before, we know that 5 times 3 equals 3 times 5 equals 15. But in matrices, A times B is different with B times A. In this question, A times B is defined, but B times A is undefined. All right, so do not mix up between these two rules. Now, we're going to do one question. We're going to do how can we get the products of, for example, here is A times B. Okay, all right, so just copy that down. We know that because A times B is defined, so we're going to find the product, whether it is exactly here, 2 times 2, a square matrix or not. See if matrix C is the same as we guess or not. All right, so now we're going to find A times B. Okay, I'll make sure that I have enough space. A times B, so A times B equal with 4, 3, 4. Write down all the elements. 2, 6, 5 times with 4, 5, 3, 2, 8, 0. Okay, and as we know that because this one is 2 times 3, 2 rows and 3 columns. This one is 3 rows and 2 columns. Write that down. 3 rows and 2 columns. And we guess that the final answer is going to be a square matrix has 2 rows and 2 columns here. Okay, let's check it out. So we know that if it's 2 times 2, we write that down. We prepare a space for a 2 times 2 matrix. And a 2 times 2 matrix is going to have 4 elements. So the first one here, so this one is row 1, row 2, and column 1. Just column 1, column 2. So the first cells here is the intersection between row 1 and column 1. So what I'll do, I write here row 1, column 1. And this one going to be row 1, column 2, row 2, column 1, and row 2, column 2. Okay, and I make different colors. The aqua, the pink, the green, and the yellow. Okay, we're going to find the value of the aqua, the green, the yellow, and the pink in here and put that out into this matrix. Now, so first, row 1 times column 1. What is the value of row 1 times column 1? It means that it's equal row 1 of matrix A times column 1 of matrix B. So it's going to equal with, just row 1 of this one times column 1 of this one. Okay, so it's equal with 4 times 4, this one times this one, plus 3 times 3 plus 4 times A. All right, equal what? You're going to use your calculator. So it's going to be 16 plus 9 plus 32. And it's equal 57. All right, this is row 1, column 1. Now turn to row 2, column 2. Row 1, column 2. Row 1, column 2. Row 1, column 2, it means it's equal row number 1 times with row 1 of the first matrix times with the column 2 of the second matrix. So it's equal with, I'm going to change the color of this one. Oops. All right. So the pink here is row 1, column 2. Okay. So it's going to equal with 4 times 5 plus 3 times 2 and plus 4 times 0 is equal with 26. Move on to the yellow one. Row 2, column 1. So now it's going to equal with row 2 of the first matrix times column 1 of the second matrix. So it's going to equal with negative 2 times 4 plus 6 times 3 plus 5 times 8 equal with, this one is 18, take away 10, 50. Okay, hope I did it correctly. And then move to last one. I'll just use this one then. Last one is the green one. The green one is row 2, column 2. So it means row 2 of the first one and column 2 of the second one. So row 2, column 2 equal with negative 2 times 5 plus 6 times 2 plus 5 times 0 equal with 2. All right. So your final answer, matrix C, for example, if we call this one a matrix C, then C equal with 57, 26, 50, and 2. This is your final answer. This one is A times B equals C. Okay? So this is how we find the products of matrix A times matrix B. All right, you can write down like this. A times B equal matrix C equal this one. Now move on to next one. We're going to do an example of the applications of matrix. Two shops, A and B, are supplied with boxes of different brands of chocolate. So 3 brands, Yummy, Scrummy, and Creamy, are shown in this matrix. So shop A, shop B. All right. So they supply 20 boxes of Yummy for shop A, 20 boxes of Scrummy for shop A, and 10 boxes of Creamy, shop A. How about shop B? Shop B, they supply 10 boxes for Yummy, 5 boxes for Scrummy, and 10 boxes for Creamy. All right. And now the cost of the boxes are, Yummy is $10 per box. Scrummy is $25 each, and Creamy is $12 each. The first question is write the cost in a 3 times 1 matrix. All right. So you have 3 things, and I want you to write a cost of 3 times 1. It means 3 rows and only 1 column. All right. So question A, the cost, we make it C equal 3 times 1 matrix. So this one gonna be Yummy, Scrummy, and Creamy. So we say the cost here is, we make it F then. Okay. Because I'm just afraid that we get mixed up between this C, and if we call this one is C, we're going to mix up with this one. So Yummy is $10. Scrummy is $25 each, and Creamy is $12 each. All right. Question B. Use matrix multiplication to find the total cost of each shop. All right. So you can see here, this one is 3 times 1. And this one is 2 times 3. The orders, okay? The orders of this one is 2 columns times 3 rows. This one is 3 rows times 1 columns. we want to find the multiplication, we have to think about the orders. So we can do, if we call this one is matrix E, okay, E like this, then if E times F is going to be, E times F is going to be 2 times 3 and times with 3 times 1. Yeah, it is defined. However, if F times E, it is 3 times 1 times with 2 times 3. It is undefined, so we can't do this one. We have to do this one. All right, so we're going to do E times F then. Okay, now matrix E is this one. 20, 20, 10, 10, 5, 10. Okay, and this one is A, this one is B, this one is A, Y, S, C. Times with matrix F is 10, 25. It has to be dollars. Actually, the dollars, you have to leave it outside the matrix. So you can write down here dollars, and it's 10, 25, 12, and this one is Y, S, C. All right. I really want to tell you what is the name of the rows and what is the name of the column of the final answers. And here how we work it out. So this one is 2 rows times 3 columns. And this one is 3 columns times 1 row. 3 rows times 1 column. My mistake. And then this one going to be defined. Okay. And the final answer is this one with this one. So it means the name of the final answers gonna be 2 rows and 1 column. 2 rows only and 1 column. So the 2 rows gonna be the name of the row. This one is the row of the final answer. Okay, and this one is also the row of the first matrix. And the row of the first matrix names are A and B, shop A and shop B. So that's why you're gonna have A, B here, and 1 column. This column is the column of the second matrix, and the column of the second matrix is about dollars. So this one gonna be dollars. So you can see that. So the final matrix will show you the cost of shop A and shop B. There you go. And again, this one gonna be row 1, column 1, and row 2, column 1. Okay. Now, row 1, column 1, row 1, column 1. So we work it out. Row 1, column 1 equal with 20 times 10 plus 20 times 25 plus 10 times 12 equal what? Use your calculator. Is equal with 820. Right? You don't have to write the dollar sign. And row 2, column 2. Make it equal. Okay. I'll just delete this one. Okay. Row 2. Oh no, row 2, column 1. We're wrong here. Column 1. Because this one have only 1 column. So it's equal with 10 times 10 plus 5 times 25 plus 10 times 12 equal with 100 plus with 5 times 25, 120, so 345. So the final answer is going to be shop A has $820 total cost. Shop B is $345. The dollar size here. There you go. So we're done with this example. The last one I want you to learn in this lesson is identity matrix, which is so simple. Any square matrices has identity matrix. only, all right, only square matrix has identity matrix. And the identity matrix is like this, all right? So the identity matrix have to be square, and the diagonal, the values of all the elements in the diagonal is 1, and the remaining is 0. So for example, this one is 2 times 2, so we have the diagonal is 1, and the remaining is 0. This one is 3 times 3, the square matrix. Square matrix means the number of rows equal the number of columns. And this one is the diagonal is 1 and the remaining is 0, and keep going with this one. So in general, we have the identity matrix has all the value of the elements in the diagonal, leading diagonal is 1 and the remaining 0. And at this stage, we just learned 2 times 2 matrix only. And remember, for me, the identity matrix of 2 times 2 matrix of any 2 times 2 matrix is this one. For example, you have A equals 2, 3, 1, 4. So this one is a square matrix, and its identity matrix is this one. Or if you have B is 0, negative 6, 4, 9, then the identity matrix of B is also this one, okay? And one of the important features of identity matrix is A times I equal I times A equal A. Before that, we learned A times B, all right? From the beginning, we learned that A times B is different with B times A. Maybe, all right? And the example from the beginning of this lesson showing that A times B is different with B times A. However, A times its identity matrix always equal with the identity matrix times A and always equal with A. So regardless the position of A and I, the final answer is always equal A. So this one is one of the features of the identity matrix.